Huntington Ingalls Industries, located in Newport News, Virginia, has been deeply involved in the construction and final outfitting of the USS John F. Kennedy, designated CVN 79, which is the second aircraft carrier in the Ford-class program. This carrier represents a significant evolution of the United States Navy's nuclear-powered aircraft carrier capability and embodies lessons learned from the USS Gerald R. Ford, the lead ship of the class. The construction of CVN 79 has involved a complex and highly coordinated series of steps over many years, including hull assembly, nuclear propulsion system installation, outfitting of flight deck and hangar areas, installation of advanced combat systems, and integration of new technologies designed to increase efficiency, combat effectiveness, and operational endurance. The shipyard at Newport News has served as the central location for every stage of this process, ensuring that all work is completed under controlled conditions with a highly skilled workforce capable of managing the technical and logistical challenges inherent in building a vessel of this scale and complexity. The shipbuilding process involves thousands of individual components, each of which must meet precise engineering specifications and be integrated in a way that ensures the carrier functions as a unified system once it is operational. In the late stages of construction, the U.S. Navy awarded Huntington Ingalls a series of contract modifications totaling more than $142 million, which were divided into multiple types of agreements, including cost reimbursable, cost plus incentive fee, fixed price incentive, and cost plus fixed fee arrangements. Each of these contract types serves a distinct purpose in the management of construction risk, cost, and schedule. Cost reimbursable contracts allow the Navy to cover expenses incurred during work that may have variable or uncertain costs, ensuring that essential work can continue without delay. Cost plus incentive fee contracts provide financial incentives to the shipbuilder for meeting or exceeding technical performance or schedule milestones, encouraging efficiency and high-quality execution. Fixed price incentive contracts set target costs with incentives for cost savings while holding the builder accountable for overruns, and cost plus fixed fee contracts provide a guaranteed fee to the contractor while reimbursing expenses, helping maintain workforce stability and resource availability during the final phases of construction. These contract structures reflect a sophisticated management approach designed to balance cost control, schedule adherence, and technical performance while accommodating the complexities and uncertainties inherent in constructing a nuclear-powered aircraft carrier with advanced systems. The primary focus of these modifications is the final integration and refinement of the ship's combat systems, flight deck and hangar operations, power generation and distribution, weapons handling, logistics and maintenance support infrastructure, and other capability enhancements. Combat system integration is particularly critical because modern aircraft carriers operate as floating command and control centers, coordinating multiple layers of sensors, communications, weapons, and defensive systems. Each system must be tested and verified individually and then integrated to ensure that it functions seamlessly with other shipboard systems. This integration process involves detailed software testing, calibration of sensors and radar systems, alignment of communication networks, and verification of weapons launch and handling mechanisms. The modifications funded under these contracts also support configuration adjustments identified during the ship's outfitting. These adjustments often arise from lessons learned during the initial installation and testing phases, from operational analysis of the lead ship in the class, and from evolving Navy requirements designed to optimize carrier performance in a variety of operational scenarios. Such configuration changes can include alterations to flight deck layout, adjustments to aircraft handling and storage systems, upgrades to weapons handling equipment, refinements in internal logistics and maintenance support pathways, and updates to the software and hardware architecture of the ship's combat systems. Another significant aspect of these contract modifications is the finalization of previously unpriced change orders. During the complex process of ship construction, new requirements, technical discoveries, and operational insights often result in modifications to the original construction plan. These changes may not have been formally priced or accounted for in the original contract, and finalizing them ensures that the Navy and Huntington Ingalls have clear agreements on the scope, cost, and schedule of the work. This formalization is important for risk management, accountability, and long-term maintenance planning. By addressing these change orders during the final stages of construction, the Navy reduces the likelihood of unexpected delays or cost escalations after the ship is delivered and operational, ensuring that CVN 79 enters service fully capable and with minimal additional adjustments required post-commissioning. All work covered by these contract modifications is being performed at the Newport News shipyard, which has long been the hub of U.S. nuclear-powered aircraft carrier construction. Centralizing construction and final outfitting in a single, highly specialized domestic location allows the Navy to maintain strict quality control, close supervision of technical processes, and rapid response to any issues that arise. It also supports the U.S. industrial base by concentrating highly skilled labor, technical expertise, and supply chain resources within the country. The workforce at Newport News includes engineers, technicians, and craftsmen with specialized knowledge in nuclear propulsion, advanced electronics, mechanical systems, and naval architecture, all of whom are essential for delivering a carrier of this complexity. Maintaining this domestic capability is a strategic priority for the United States, ensuring that the Navy can continue to build and maintain a technologically advanced carrier fleet for decades to come. The timeline for completion of the work supported by these contract modifications is projected to extend to June 2026. During this period, the ship undergoes the final stages of outfitting, testing, and operational integration. Testing includes verification of all shipboard systems, including propulsion, electrical power, communications, weapons, and aviation support. Integration trials simulate operational conditions to confirm that the carrier can sustain flight operations, coordinate a full air wing, and conduct multi-mission operations effectively. Each system is tested individually and in combination with other systems to ensure reliability and operational readiness. The goal is to deliver a carrier that meets or exceeds all performance specifications and is capable of immediate deployment into fleet operations. While these contract modifications are not as large as previous ones that shifted significant work from post-shakedown availability into baseline construction, they are essential for finalizing the ship's configuration and ensuring that all systems operate as intended. The USS John F. Kennedy, once completed and commissioned, will serve as a forward-deployed platform for the U.S. Navy, capable of supporting sustained air operations, power projection, maritime security, and rapid response to global contingencies. As the second Ford-class carrier, CVN 79 incorporates improvements over its predecessor, including enhanced sortie generation rates, increased electrical power availability, more efficient weapons handling, and improved flight deck and hangar operations. The work funded by these contract modifications ensures that these capabilities are fully realized and that the ship meets the Navy's current operational requirements. CVN 79 will provide the fleet with a modern, highly capable, and sustainable platform that strengthens U.S. naval dominance and supports strategic objectives worldwide. The contract modifications also demonstrate the Navy's commitment to maintaining programmatic control, reducing operational risk, and ensuring the carrier is delivered ready for deployment. By funding system refinements, configuration adjustments, and change order finalization during the pre-commissioning phase, the Navy ensures that CVN 79 will require minimal corrective work after entering service. This proactive approach maximizes efficiency, maintains schedule integrity, and safeguards the long-term operational readiness of the vessel. The integration of lessons learned from the USS Gerald R. Ford ensures that CVN 79 benefits from operational insights, reduces potential maintenance challenges, and improves overall shipboard workflow and efficiency. These efforts collectively highlight the United States Navy's focus on sustaining technological superiority and operational readiness through careful management of advanced shipbuilding programs. By funding these contract modifications, the Navy ensures that the USS John F. Kennedy will be a fully capable, reliable, and technologically advanced aircraft carrier that can support forward-deployed operations, maintain global maritime presence, and project power in multiple regions of strategic importance. The work also reinforces the domestic shipbuilding industrial base, ensuring that the United States maintains the workforce, technical expertise, and infrastructure necessary to produce and sustain nuclear-powered carriers over the coming decades. The USS John F. Kennedy, once completed, will be a central element of the Navy's ability to respond rapidly to emerging threats, conduct sustained maritime operations, and uphold U.S. naval dominance worldwide, representing both a continuation and an enhancement of the Ford-class program's strategic and operational capabilities. This phase of contract modifications, while routine in the context of large-scale carrier construction, is critical for delivering a fully operational ship. It ensures that CVN 79 systems are integrated, tested, and refined, that construction adjustments are formally agreed upon, and that the shipyard workforce can complete work in a controlled and coordinated manner. It exemplifies the complexity and scale of modern carrier construction and demonstrates the Navy's methodical approach to delivering advanced platforms that maintain the United States' technological and operational edge. By completing this work domestically, the Navy preserves national expertise in nuclear-powered carrier construction, strengthens industrial resilience, and guarantees that CVN 79 will enter service as a capable and sustainable centerpiece of U.S. naval power.